Great to see you here again. My name is Luc de Koster, founder of the Koster Academy. And in this new series of videos, I will talk about samples, the sampling error, and the central limit theorem. In this first video, I will talk about the sampling error. But before we start, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look. What is this? What is the sampling error and why is it important? Now, we want to have an idea about a population, but testing the entire population is in many cases impossible because we're destroying the data, we're destroying the things that we are measuring, and it will be destructive sampling. It means that we cannot use the items anymore, or the population is so large that we can not ever do the entire population, test the entire population. They do it from time to time when they have the census. They are trying to measure all the parameters of a population, but it's basically very expensive and very complicated. We try to take a sample, and taking samples is not so easy as it may be. We have to find representative samples, and we want to have randomness. Every sample has to have the same probability to be chosen as any other. When we have what we call bias, or when we are sampling in a wrong way, for example, there were some examples where people were sampling using telephone numbers, and of course you don't have all the people, you only have a selection of the people, and you don't have a representative sample. Some methods of taking samples are not always the way it should be. So basically, when we have some problems with the sampling, our data are not really valid anymore. Now, when we look at the validity of a sample, we have to find some simple rules that we will discuss in this chapter. Let's have a look at a sampling error. And the sampling error is the difference between the sample average and the population average. Here we have a total distribution. So this is a population. We have 20 people, can be a company or something, and we look at different parameters, the length, the age, and the income of the people. And for all of them, we can calculate the average and the standard deviation. Now let's look at a sample. And when we take a sample, we find here the sample 1, where we have 5 people that we selected, different numbers randomly chosen, and we can calculate the length, the age, and the income of those people. We can calculate these averages. So when we look at the sample averages and the population averages, you see that there are differences between them. And what we're going to do now is to look at, first of all, the sampling error when we look at the length. We find mu is 170.1 and x bar, the sample average, is 172.6. Applying the sampling error x bar minus mu, we find that in this case the sampling error is 2.5. Now we look at the age. And when we look at the age, we find that mu is 39 and x bar is 31.4. So when we have x minus mu, we find minus 7.6. So we have now a negative sampling error. We can do the same for the income, and we find mu equal to 54.9 and x bar 66.8, which gives us a sampling error of 11.9. Now this is something that we can repeat. This is the overview of the sampling errors for sample 1. What we can do now is get another sample. We look at sample 2. We have a different random sample. We again sampled 5 people from the population, and we have their lengths, age, and incomes, and we can calculate the average and the standard deviation. So let's look at those elements together, and for sample 2, we find that the average of the length is still 170.1 because this is the average of the population, and x bar is 176, which gives us a sampling error of 5.9, which is a lot larger than the sampling error in the previous example. Now we look at the age. We find with the age mu still 39 and x bar 36.8. We find a sampling error of minus 2.2. And finally, we look at the income, and there we find a sampling error of 2.3. So we see that we have two samples, and each of those samples, they have different sampling errors. Now, what can happen when we look at the samples? Let's look at the length. We know the average is 170.1, but let's now just assume that we take 5 samples, 5 people from the population as a sample, and those are the people with the smallest length, the shortest people. Then we will have basically a negative sampling error, which is in absolute value the largest sampling error on that side that we can have. But we can have the same thing. We can select the tallest people, and then we will find a complete different element. We will find a different sampling error, which now will be the positive, the most maximum value we can have. But we can have everything intermediate. So sampling is not so easy as we see, because some things can happen, and the probability that selecting the shortest people, the 5 shortest people, or selecting the 5 tallest people, they all have the same probability. So we can, let's say, we have to be careful when we do sampling. And it's clear when we take larger samples, we will see that the sampling errors will be smaller because we have more values that we are selecting, and we're coming closer to the average. So that was it for the sampling errors. Basically, that's what I wanted to talk about in this video. So before leaving the video, don't forget to click the subscribe button, click the bell button, and every time we have a new video, YouTube will inform you about it. Thank you, and bye-bye.